Alright. So, Shiva, so I'm not recording your video, so you can be on the video, okay? I'm recording it on the iPad, so you're safe, don't worry. Alright. Now, again, this week and the next week, we are going to dedicate again for STAAR test only. So whatever doubts, whatever topics you want to cover, whatever clarification you would want, that's all we are going to cover as part of this week, today and the next two classes. And even in after last two classes, right? Your dad is here. Sit down, it's okay. I'm not teaching you anything. Last week, sit down, it's okay. You sit down, be comfortable, okay? So, so next 2 weeks, we'll focus on STAAR test. So this is an opportunity for you guys to tell me this is a topic I want to learn. I have some doubts, some questions you want me to solve. I will do it. From May beginning, I'll go back to my normal pattern where I'll pick up a topic, keep teaching you guys, explain, give you assignments, whatnot. Okay. So, what do you guys want to learn today? And it could be within the syllabus, it could be outside the syllabus also. That's okay. Within maths. I'll probably not try teaching science today. Okay, that is it. Alright. Think a little, tell me. How about you with it? Let Pranit think.
Okay.
Or Sivatsa, I want you guys to tell me which topic you would want me to teach you so that I can focus on that. Yesterday, yeah.
So I'm gonna go with slope work problems. So we just have arm and slope.
Slope work part, yes. That's a good one.
And even surface area or water.
Just give me a second, okay? Yes, ma'am.
Yeah, sure.
No, I think we'll be starting this month because next month we are going to India.
Okay.
So we won't be here for next 3 months. No, we'll be back.
Okay.
And we'll join back in August. Is that
That's fine. Yeah. Enjoy your trip. I'm going to India too. Tomorrow I'm going to India, but I'll be back in 2 weeks. I don't
Oh,
get
only
summer
for
break.
2 weeks.
I
Oh,
don't
okay.
get summer break.
Yeah,
I'm
he's
just
taking.
going yeah.
We will be going for summer break. No, all 3 months.
So do good in your STAAR test, okay? And next week I'm not here, but I will be scheduling the online classes for them tomorrow.
Okay.
So I will do it a little later in the evening because if I go at 4 o'clock, I'll be 2:30 in the morning.
Yeah.
So I'll do it at,
Yeah.
try to do it at 8 o'clock for them, Saturday, Sunday.
Mm-hmm.
I hope they can try.
Yeah.
Yeah?
He'll be here. He'll join.
Okay.
Yeah.
Alright.
Okay, thank you.
Yeah.
Thank you.
Alright. Okay. So yeah, slope part is one. What is there for you?
Slope.
Okay.
No. There's something else. I'm fine with everything else. I'm basically fine with everything else, but I'm not sure with other people.
Okay. Okay. So slope I heard from Sivatsa. So that is one.
Binomials.
Binomial. Okay. Alright. So let binomial we'll plan for doing it in the next class, okay, when I'm doing it online, because what I would need from you is use your mom's phone or daddy's phone, send me a message that next class please make sure that you're covering binomial. I'll look at the entire syllabus for you guys and then we'll cover that. Okay.
Okay.
Alright, so let's look at the slope part. Again, we'll try to make it as simple as possible. So this divide and conquer that we saw yesterday, that you guys remember, right? Making the graph. This is your x-axis, this is your y-axis. When we say slope, this is a positive slope, this is moving upward, meaning when you increase the value of x, corresponding value of y increases. This is a negative slope, which says if you decrease the value of x, if you increase the value of x, value of y decreases. That's why it is negative. So upward slope means when you change the value of one of the parameters, which is x, mostly we talk with respect to x. Okay. Say if I increase the value of x, the value of y increases, meaning the line is going up. The slope is positive. If I increase the value of x and the value of y decreases, this is a negative slope. Yeah, this is the conceptual part of it. Now, let's try finding out. Oops, what did I do? There was no need to do so. Okay. So let's try finding out what is the slope. So this is a line. This is one point x1, y1. Okay. This is second point x2, y2. Yeah. Sorry.
Isn't it the x2 minus x1? Wait, it's rise over run, so
Y2,
y2
y,
y1.
yeah, that is how it is. But I was not jumping there, I was just going step by step. Okay, that's what I'll do. But what I'm trying to tell here is, when you look at a line segment, you're essentially looking at 2 points connected together to make a line segment. And the 2 points, I have my coordinates for these 2 points as x1, y1, x2, y2. Meaning, x coordinate is x1, y coordinate is y1. Here the x coordinate is x2, y coordinate is y2. Okay. Now, this is the first point. This is the second point. Okay. So how do you find the slope? You always look at, let's look at some practical examples. Okay. I mean, I can tell you that okay, y2 minus y1 by x2 minus x1 is a slope. I don't do that. If I do that, I'm forcing you to memorize. That is not my objective at all. That is something that somebody is waiting for the teacher. Okay, good. The teacher doesn't have to be worried. Why do we talk about a slope even? If I'm here, okay, this is a plane surface. I'm standing here. I come here. It's just a plane surface. Very easy to move. Let's say if you ask me to do trekking, I'm a very lazy guy, I will not do it, I don't do it. What will come to my mind? Do I have to climb a very steep hill? Or is it like a plain road? If it's a plain road, it takes less effort and energy for me to cover the distance. If I have to climb up, it needs a lot of stamina and strength to do it. So I always compare my current state with the future state. What will change? Let's say I say that I'm going to India. What will change by going to India? My coordinates will change. Google Map locates me here in the US right now. When I go to India, my coordinates will change in India. That's the first thing that will change. What is that change? Future minus current. That is the change. Right, Sivasal?
Yeah.
So, I have, let's say, $100 in my account. I made some more saving. My state changed in bank. I saved some more money in the bank. My value changed from 100 to 300, let's say. I saved $200. What is the change? It changed from 100 to 300. How do you know to change? From the future, you subtract the current value. That gives you the change. Okay?
Okay.
Now, same way, if you look at what in this line now, I was here, x1, y1 was my coordinate. I traveled to this place, following this line. My new coordinates are x2, y2. What has changed? My y coordinates changed by this much. Yeah? My x coordinate changed by this much. Now, you will say, okay, this is the change in y, This is change in x. Then you understood. Y slope. If everything was here along this line, this was a straight line. This is moving upwards. This is moving further up. This is moving further up. What is changing here? The slope of the line or the steepness of line. In which direction it is changing? In the y direction, towards y. That is why you always say, how much is my change of x against y? How much is, see here, any point that you see, this is one point, x3, y3, let's say, this is x4, y4. You always say, okay, how much x is changing for change of this? How much x is changing, let's say x5, y5. How much x is changing for the change of y? So you always look at what has changed in y. And for that, what has changed in x? That is how you look at it. Meaning, how much we are moving in the y direction, or okay, how much I'm moving horizontally for every change in y direction. That's what is defined as slope. Now you look at this one. Look at this one. Y equal to mx plus c. Okay? Mx plus bc. It's a constant anyways. Okay? Now, imagine when b is, let's say, 0. Just make it up. Okay? I'm saying b is 0. The constant is 0. So y equals to mx
Plus
is
0.
mx plus 0 is mx. Yeah? What I mean by that is, I'm saying that it is not intersecting on the y-axis, it's going to the origin. That's what I'm saying. I'm only talking about y equal to mx. So what is m? M is my slope. What is the value of m?
Y by x.
Okay? So, slope has to be read as what is the value of y against x? Since we are talking about 2 points, it's always better. I mean, if you have to find out the slope, right? Just by looking at 1 point, it will give you value of y in comparison to x. But if you want to really know the slope, you will compare 2 points. Okay, is it tapering down, moving up? How is it? Yeah. So that is why this y, change of y against change of x. Yeah, that's how we find out the slope of a equation or a slope of a linear equation. So, see what's up. Before I go further, are you with me so far?
Yeah.
Okay. So, very simply put, this is the slope-intercept form. If you don't want to remember whatever I did, if you look at the slope-intercept form, what is the slope and what is the intercept? I'm saying if my intercept is 0, that means everything that I have is slope. Y equal to mx. This is my, only the slope part I'm taking. Now, what is the slope? Slope is, if my intercept is 0, meaning it's going to the origin, it's cutting here. M equals to y by x. What it means is, for every change of x, how much y is changing. Yeah? Or what is the corresponding change of x for every change of y. In any which way you represent or interpret or read. So, you look at the start and end of y, subtract that, divide that by this. This is how you find the slope. Now, let's look at few equations, and then probably it will be able to. So let's say if somebody says that your x coordinate is 5 and 3 for 1 point, and second point is minus 3 and 8. Find out the intercept. Sorry, find out the slope and intercept both. Let's see what we can find from this. So my first point's coordinate is 5 and 3, and second point's coordinate is minus 3 and 8.
I can't see. Can you move a bit? Yeah, right now I can see.
Yeah. So 5 and 3 is the first coordinate for the first point, minus 3 and 8 is the coordinate for second point. Can you find out the slope? And will you be able to find out the intercept from this as well? Okay. Let's see. See what's up? You got the question?
Yeah. We just need to find the slope and the y-intercept from the coordinates.
Yes. So I want you guys to find out the slope and the intercept both. Y-intercept.
So is the first coordinate 5, 2?
No, it's 5 and 3. The second one is minus 3 and 8. 5, 3, minus 3 and 8. Okay, whoever is done, let me know.
I need help. I need to find my y-intercept, but I don't see it. But I don't know how to find the y-intercept. I found my slope value.
Okay, I don't know whether this question is correct or not. Okay, I mean, I might be wrong with the question. Yeah, right? Okay, let's see. So basically, see, whenever I talk to my students, right, I tell them that I'm not concerned about the answer. I'm more concerned about the concepts and the approach that you follow for solving a sum. So here, I told you guys what is the slope intercept form. I've given you the coordinates. I don't know what the answer is, whether the question is correct or not. I'll just apply whatever I know in the equation and see what is that I get to know. Yeah. Let's see what you continue. I mean, put that. See, when you think, when you do, you'll be able to find it out. If the teacher is down, you'll point it out. Okay. Let me see what did you do. Yeah, very nice, very nice. And another thing that you might want to remember as a clue is, once you find an equation, any and every line following on that equation will satisfy the condition. Any and every line, any and every point on that line will satisfy that equation. Okay? So these are the two things that you have to remember.
Okay, I'm done finding the answer.
Okay? I would not really care much about the answer.
I'm
We want to
done
see.
solving the equation.
Okay, so let me see how did you solve? So that will give me a view into
I
whether.
also did the draw the coordinate graphing.
Okay. You found the equation now, so you know what is the slope and what is the intercept. B. And how did you find b equals to 8?
I drew a coordinate graphing on the other side of the page, and I used the rise over run
Okay.
thing.
Okay. Now just let's see. So here you said
Yeah, u by is 5. 5 divided by 8. Do negative 8.
okay. So or second thing you can do is you can just pick one point, one of the coordinates, 5 and 3, and substitute in this equation. Instead of y, you put, let's say, you put the first point, y equals to 3, x equals to 5. You put it here, and that gives you the value of p also. You don't have to try much. Because if you have the point, which is drawing a line for you, any point on that line will satisfy this equation. So here you pick up since you know you have two pairs of x and y that you know, you can just substitute that value here. That will give you the value of b,
Okay.
and that makes your.
Okay, but is my y equals to mx plus b right?
Yeah.
Okay, I really have a pen.
Oh, okay. Yeah. Okay. See what's up. Are you
Yeah.
close to being done?
Yeah. I mean, I forgot how to do y-intercept, so I'm trying to do it.
Okay. So I would just want to know what is the value of your slope and what is the value of b. If you can tell me these two, then I would be able to assume that you have done it.
I think it's 8 by negative 5.
Is it 8 by negative 5 or it's minus 5 by 8?
Oh, I did it. Oh, I'm sorry. I did
Yeah.
it.
y2 minus y1 by x2 minus x1, that will be your slope, right? So the second point was minus 3 and 8. Yeah. Yeah.
Makes sense.
Yep. Alright.
Uh-huh.
So here, what is the takeaway? Takeaway is I did not teach you guys anything. Because these are the concepts that you all know. Okay? I'm just helping you guys do a recap, nothing more. I would be wrong if I say that okay, I taught you guys how to find out the slope and coordinates. Okay? Or slope and intercept. Because you guys were already knowing what is the slope intercept form of a linear equation. Okay? You just substituted the value. I just showed you how to do it. That's it. So, no credit for me. Okay? Now, summary of what we have learned or practiced today is that whenever you are talking about any linear equation, you can either use the slope intercept form or you can use the standard form. So if you look at the slope intercept form, that is y equal to mx plus b or c, whatever it is, and standard form is ax plus by plus c equals to 0. You can choose one of the two forms, but interestingly, this is the most commonly used form. Okay, you will see that this is used more often because any line, segment or line that you want to talk about, you can recognize that by two things primarily. One is slope, upward, downward, positive, negative, and where does it intersect the x or y axis. That is good enough information for us to draw a line basically. And that's why people tend to get to this one. I'm not discouraging you guys for using standard form. This is also a form, and you will probably end up solving a lot of sums with this one also when we go through this chapter one more time. But then you will see that it's like 70-30. 70% of sums you will solve using this one, 30% here. Now in this one it's very simple. Any equation that you have, and if you have, let's say, an equation like this and you have a line like this, you can handpick any point, literally any point, and that will satisfy this condition. That is the deal about the linear equation. If you are talking about linear equation, if you pick any point on this one, any point that you like, pick a point here. If you don't like negative points, pick a point here. Up to you. Okay? any and every point on this line will satisfy this condition. So the deal is, if let's say you got 2 points, you form the line, you're trying to find out the value of b. No big deal. You can just pick that point which is on the line, which is on the coordinates that you know, substitute the value of x and y here. That gives you the value of b. Because the agreement is any and every point on that line will follow that equation. Otherwise, it's like every baby in the family has to follow the rule of being home by 6 o'clock to start studying. Yeah? There's no baby who will be given that luxury, okay, you can wait till 8 o'clock. No, I'm not saying here it's 8 till, you have bright sunlight till 8. But I'm saying when we were small, I grew up in a joint family where we were like 20 siblings, 20 cousins together, okay. So it's like, the rule was by 8 o'clock, by 6:30, everybody has to be home. Otherwise, you'll not get dinner. That was a way to enforce discipline. It was never that if you get late, you'll not get food. I'm saying it was a way to enforce the discipline. So, same way here. Any of the point that you see here on this line, that will follow this one, this discipline. So, you can use that value to find out the unknowns by substituting it in the line equation. Okay, what next? Any doubt so far, Sivatsal?
No.
No? How about you, Mitran? No? Praneet? No. Okay. What next you want to learn?
Can we do a review on how to find surface area volume of 3D shapes?
Yeah? Okay. Good. We have done that in the past, but
Just a quick review because it was
Yeah.
7th grade when I did that.
yeah. So Sivatsal, for you, Praneet, our new friend in the class, he's asking us to do a quick review of surface area and volume of the 3D shapes. Are you okay with that?
Yeah, that's fine.
Yeah, okay. Alright. 3D shapes. Look at my slipper. If I draw a line around the border of this, you will see a shape of the slipper here on the surface. That is something that I can draw on a surface. I can use my slipper, I will not do that, but still I can put my slipper on a piece of paper and still draw it, right? But, so what that means, that is a two-dimensional shape. It's a sheet. It's a piece of paper on which I can draw.
Oh, yeah.
So, horizontal and vertical. That's why it's called 2 dimensions. 90% of things that we do with geometry is on 2 dimensions. Now, yes, you're saying something? Are you saying something?
Sorry.
No problem. Okay. So 2 dimensions is nothing but a surface where you draw something. Now, triangle, smaller triangle, baby triangle, tiny triangle, invisible triangle. What is the difference? These are all triangles, but they are taking different space, different amount of space on the surface where you are drawing them. This is bigger, this is smaller, even smaller, tinier, taking less space. The space taken by any object on the surface is called area. Yeah? No doubt. Now, you have heard, so if I talk about this, a rectangle, a square, a triangle, trapezoid, these are taking different space, different amount of space on the surface when I'm drawing them. Imagine if my sheet was this big, where I was trying to draw it. Trust me, none of this would have fit in here. They did more area, more space. I did not have enough. Yeah? So this is area part. No doubt, right? Now somebody says perimeter. I'll come to surface area and volume also, but I want to make sure that I'm covering the basics and I'm going there, okay? Somebody says perimeter. Perimeter is nothing but the boundary wall. This is my form. If I have to barricade it, how big the wall would be to barricade my form? This plus this plus this plus this. That is the perimeter. So if you talk about rectangle, you know All the four sides you will add. Since you know rectangle is length and width, this is also length and width. Opposite sides are equal and parallel. 2 length plus 2 width. So that's how the perimeter comes out to be 2 times length plus width. I will not ask you guys to memorize this formula. You will be able to figure out by seeing the rectangle. That's why I'm not asking you to. If you're talking about a square, you know that property of a square is all four sides are same. What is the perimeter? This plus this plus this plus this. All are same. So 4 times length. Yeah. Now area. Do you guys know what is the area of a rectangle or a square? Length times width. It is length square. Triangle.
One half times
Base times height.
base times height.
Yeah.
Or you could do base times height divided by 2.
Huh?
You could do base times height divided by 2.
Either way is fine. Yeah. Same thing, right? I mean, you can write this as 1 into base into height, or you can write this as base into height divided by 2. Either way, it's the same thing. Right? This formula you guys know. I'm not stressing on that one, and I'm not even trying to explain you guys how this has come. Any and every formula that I teach you guys, I make an attempt to explain you how the formula is derived. Okay, so that way you don't end up memorizing it, you end up understanding it. But I'm not explaining that to you, assuming you guys have learned it in the past. If not, let me know. I'll teach like a baby. Okay. I take the pride in explaining the concepts. I don't like myself for telling you this is what you have to memorize. Okay. Now, so basic shapes. I just covered the basic shapes. Then you know about the circle. You say okay. What is the area of a circle? Pi r square. Pi is 22 by 7. Yeah. Value of pi is this. You guys know it?
Yeah,
Okay. 3.14 whatever. Right. If you convert this fraction to decimal, that's what will come to. Now, what is the perimeter of a circle?
2 pi r.
2 pi r. Yeah. So there is nothing happening here. What's happening is these formulas are dancing actually. Look at this area is 2 pi r. You have 2 pi and r. When you look at perimeter, this 2 number dances and comes here in the front. Yeah. So pi r square 2 pi r. This is the basic thing that I keep giving lame examples to help you guys memorize it. But that is not the intent. Intent is something else. Now, talk about a shape. This is more like a thing that I don't know about you guys, but I used to steal that from my face and keep on eating it all the time. Called ice cubes. Why cubes? They look. These are the shape that is derived from a perfect square. You have a square, length into width, length into length square, and then if you extend it to the same height as the length, that is when it becomes a cube. If you have a rectangle, if you extend some height into it, that becomes a cuboid. That's the basic difference. Here in case of a cube, all the sides are of same length. In case of a cuboid, this is not the case. In case of cuboid, it's an extension of a rectangle. If you guys have seen and if you have bought the printing paper bundle from Walmart or Costco, what you see is a rectangle. And if you see all the sheets put one after another, it literally looks like a big matchbox. That is nothing but a cuboid. So the rectangle is extended, or rectangle after rectangle you keep on adding, okay? And that's what makes a cuboid. Imagine this notebook was much more thicker. That would have been a perfect example of this cuboid. What it contains is rectangle after rectangle after rectangle. You're just adding multiple layers. Now, if you have seen the ladies at home putting the bangles, what is that? That's an example of a cylinder. where you're putting circle after circle after circle, keep on stacking them one after another, that makes a cylinder. Make sure that they are symmetric, okay? Yeah. So here, if you try visualizing a cube, you are stacking square after square after square to an extent where the length and this height becomes the same. So the ice cube that we get on our fridge, they look fancy. Sometimes they put an animal shape also. That is not a cube actually. That's not an ice cube. Ideal ice cube would be a cube which is 1 centimeter in length, 1 centimeter in width, and 1 centimeter in height. That's when it qualifies to be called a cube. Now, when you extrapolate that and think of a cube, anything that has same length, width, and height is called a cube. So let's say if your length is 5 centimeters, and this is also 5 centimeters because this was square, and then you extend this to a height of 5 centimeters. That becomes a cube. What is the volume of this? What is the volume of a cube?
But I know the formula. It's area of the base times the height.
Area of base times height. Now, are there simpler way to relate that? You have the area of the base, that is a rectangle. You are putting rectangle after rectangle after rectangle. And how much volume it will have, how big the shape will be a function of how many pages, how many layers you have stacked. Meaning how tall you have made it. So that's why it is always area of the base multiplied by height. So in case of a cube, it is length into length, that is your area of the base. Yeah? Multiply that by height. That becomes your volume. In case of a cuboid, length, width is different and height is different. You don't have any agreement saying your length, width, height has to have any relationship among them. They can be very different. But at the end of it, these are rectangles stacked after one another and making the height. So area of the base times height. Yeah? See what's up? Are you with me so far?
Yeah.
Okay. Now, this is the volume, but one thing we missed was we did not talk about what is volume. We talked about area. Area is the space that is taken by the object on the surface. What is the volume? Let's say I put on a lot of weight. Okay. Let's say I put on a lot of weight and I become this fat. How many people of my size can accommodate in this room?
None.
Maybe 3 or 4. No, this is still okay, manageable, right? I mean, this much height. Let's say I'm occupying space till this much. Next person of my size will go till that much, till your chair. The third person will go one more layer, maybe 4 people. If I remain like this, knock on the woods. If I remain like this, how many people of my size can stand in this room? Probably 30, 40, 50. Yeah? What it means is, this room has a capacity. How much it can hold. And I have a capacity of how much space I need. Based on how fat, thin, lanky, fit I am. Okay? So, this is my volume. And the capacity of this room is this room's volume. Meaning, how much it can hold. What is the volume of this guy? Is the amount of water it can hold. Yeah? So, volume is nothing but the total space in 3 dimensions taken by any object. So, when you look at area, you're talking with respect to 2 dimensions, length and width. When you talk about volume, you're talking about the space taken by something in 3 dimensions, length, width, and height. Let's say if I'm short. Somebody can, if there is a situation where people have to accommodate in this room, somebody will stand on my shoulder also to, as long as they can fit in here, right? So, because otherwise this volume is not used. This volume is still there, but, right? So I'm saying volume is nothing but the space taken by anything in the 3-dimensional space, length, width and height altogether. And that is what helps you decide how much of something you can accommodate in a given space. If I need to drink a lot of water, I'll pick up a water bottle which can hold enough water. I'll not pick up a tiny bottle like this. It'll not have enough volume of water if I need more. Right? So volume is something that you can always relate. Let's say if there are 10 people staying in this house, I need a water tank. I mean, here we don't have water tank, but in India, right, we used to have a water tank installed on the roof, right? Depending on the amount of water you need to consume, you will keep the water tank bigger or smaller. Yeah? So that you have enough volume of water. So volume is nothing but the amount of space taken by that object or the amount of any substance that it can hold. Now, volume is that part. So that we learn how to find out the volume of cube and cuboid. Now let's look at a right cylinder. Same thing. Like what Mitran said. Volume is area of the base multiplied by height. What is the area of the base? This is nothing but a circle. Yeah? That is pi r squared multiplied by the height. Depending on how many bangles you are taking one after another. Look at this volume. This is a cylinder. Perfect example of a right cylinder. Yeah? So area of a base multiplied by height. If I want my boiler to be bigger to get more hot water, I'll probably go for something which is taller than this, provided I don't end up breaking my roof. Yeah. So this decides the total volume. So area of this multiplied by height. Yeah. So this is the volume. How do you get the volume? How do you relate and figure out the volume? Okay. I'm not asking you guys to memorize. I want only you guys to remember the area of a square rectangle, area of a triangle, area of a circle, and then rest all you can derive. Now, the other thing that comes into play is called surface area. What is surface area? Let's say you guys want me to look younger. I'm getting older now. You'll say, okay, if you color yourself green, you'll probably look younger. Yeah? What will you do? If you have to color me green to make me look younger, how will you find out how much of paint you would need? That is my surface area. Whatever is the surface that is visible, right? That is what you would want to color so that I look younger. That is surface area. If I get tired of seeing the color of the bottle, but I still like it, I don't like the color. If I have to color the bottle, what will I color? All that surface that is visible. I'll not color it pink, but yeah, I'll pick up a color that goes by my character, right? So I'll probably use maybe a blue. Yeah. Surface area tells me how much of paint I would need, how much surface is exposed, which has to be colored. So that is surface area. Now, imagine a surface area for a cuboid, which is nothing but a dice. I'm not sure if you guys have played Ludo ever or Snake or Ladder. There's something that you roll, right? Which has number 1 to 6 written on it. Yeah. All of them are same because this is a cube, perfect cube. All the sides are perfect square. Everything is length, length, length. Everything is matching, right? All the sides are matching. What is the surface area? You have 6 sides here and all sides are same. 6 times the area of one side, which is length into length. Yeah. If you are looking at a cuboid, what do you see here? So Shivatsam, stop me if I'm going fast, okay?
Oh, shoot.
So we had talked about volume of cube, cuboid and right cylinder. We talked about, so when you say cube, cuboid, those are prisms also, right? Those are called prisms also. Sorry. Then when you talk about, when you're talking about the surface area now, right? So surface area is very simple. We have to always visualize that object. That's why I started with coloring me. Don't try to color me. My passport, my green card, everything will get cancelled. Okay, if my color changes there in the passport. Yeah. So, but coming back to on a serious note, surface area is this visible surface that you can use for any purpose, be it for painting, be it for I mean, let's say when you need a surface area. I mean, classic example would be the Amazon products that we buy, right? They come in a box, like one you see right behind you, correct? They decide how big it has to be to hold a product that I have ordered. And once they decide that, they have to build that box using good enough amount of cardboards. Yeah? And that is exactly, if you just cut it open, whatever you see on the floor after cutting it open completely, that is nothing but the surface area actually. Yeah? Because they are able to derive how big the cardboard they would need for making a box. Because ultimately they fold it and make the box, right? So that's one classic practical example that you would see. Here, when we talk about a cuboid, we all know this is made by rectangles, where you have length, width and height. So let's say this is length, this is width, this is height. I need to buy the markers. This is length, width and height. Yeah? Now, look at it more carefully. What do you see? This side and the side in the back, this side, are similar. Same, exactly same. This side that you see here and this side in the back are exactly the same. This side on the top and the one on the bottom, these are also exactly the same. So basically, your total surface area is 2 times the surface area of the top. Let's say I call this side 1 plus I call this as side 2. Yeah? Now look at what is the surface area of the top. Here it's a rectangle. What is the area of this rectangle? Here this is length, so this is also length, and this is width, so this is also width. So it is 2 times area of the top, that is length times width. The top and the bottom is covered. Now side 1, if I am calling this a side 1, here this is also a rectangle. What do you see here? Width and height. These are the 2 things, right? Plus side 2, which is this one. Yeah? Here, what do you see? Length and height. This is your surface area. Yeah? So, see what's up? Same thing. Let me just explain to him. So, when I'm looking at the surface area of a cuboid, what I'm finding is, I'm finding 3 pairs of matching sides actually, right? Like if you see this one, this side and this side are same, this side and this side are same, this side and this side are same. Yeah? So that's why I'm saying 2 times of 3 sides. And then every side I see which one is my length, which one is my width, and then I'm finding out the area. Yeah? So that's how it becomes 2 times length into width plus width into height plus length into height. Yeah? Yes.
Yeah.
What about lateral surface area?
Lateral surface area. What is the lateral surface area here?
The sides.
Yeah. So you see, here there is no formula that I would want you to memorize. You will say, okay, lateral surface area. You don't want to consider the top and bottom. So you are talking about this side 2 times, this side 2 times. Here this side length and height. 2 times length into height plus this is width and height. So 2 times width into height. So 2 times length into height plus width into height. Again, I would not want you to memorize this, because when you memorize it, if somebody messes up with this and calls this as height, this as length, by putting it upside down, everything goes for a toss. Don't worry about it. Just look at it, visualize it, see which side is what, and then apply the formula. Yeah? So Pranita was asking about that lateral surface area, meaning exclude the top and bottom. So that was the discussion we were having just now. Okay? See what's up? Are you with me?
Yeah.
Okay. Now, so we looked at cuboid. We have not looked at one interesting one where I have bothered Mithran for 15 minutes. Mithran and Srivatsa for 15 minutes explaining it, and I will do it again. So, that is on the cylinder, right cylinder. Okay. Volume we know that the area multiplied by height. So pi r square multiplied by height. Okay. Now surface area. This is where there are two things that come into play. The lateral surface area that you were talking about, the curved part, and then this top and the bottom. Okay. Your top and bottom is easy. This is pi r square. This is also pi r square. Both are circles, right? If you have to paint, let's assume that this straw is not there, and this is symmetric. Then this is a curve, and then this top and the bottom. This is a circle. This is a circle. Pi r square, pi r square. This part is covered. Now this curved part. This curve. What is that? What is that area? This surface area. Exclude this part, meaning the lateral part that you are saying. How much is that?
Almost, it's just the height. Mostly, it's most of the cylinder.
Most of the cylinder, yeah, only the curved part that is exposed. This part, only this part, not the top and bottom. Top and bottom we have calculated pi r square, pi r square. Now the curved part. Mithran, do you remember what is the surface area of the curve?
2 pi r h.
Mm-hmm.
What I was going to say is area of the two bases plus the height.
Mm-hmm.
Okay.
Area of the two bases plus height. So two bases area is pi r square plus pi r square plus area of the height, meaning this curved part. Okay? I'm just writing it down right now. So this becomes 2 pi r square. 1 pi r square, 1 pi r square, 2 pi r square. Now the curved part. Srivatsa, do you remember what is the area of the curved part of the cylinder?
You mean the rectangular curve part?
It's the curved part which will convert to a rectangle once I repeat myself.
Okay, so I guess it's like I know only the formula for volume
Mhm.
for that thing.
Okay. Now when I will do something, you'll probably be able to recall. So, I was never a very good student, okay? I never believed in studying. I never studied like study. I studied like playing with things. Okay, that's what I'm trying to do it for you guys. And that's where whatever I learned, that remained with me as a concept for much longer time. So I'm not saying that become like me, but I'm saying there's some good thing that you can probably borrow from me. Now look at this. What is this? A cylinder? I don't want to care about this part and this part. I have found it out. Okay? This is a cylinder. Okay? Srivatsa, you can see it? Yeah? Now, the curved part,
Top is your circumference.
yeah, the curved part became a rectangle. If I know this side and this side, I can find out the area of the curved part. What is the curved part? Look at this.
Circumference.
This is circumference or perimeter of the circle. And then the height. What is the circumference of the circle?
2 pi r.
Yeah. So this is nothing. This side is nothing but 2 pi r. This is the circumference 2 pi r. See what's up? You can see it?
Yeah.
2 pi r.
You mean the base?
And then and then the height. No, I'm not saying the base. I'm talking about this. See, this is my cylinder, right? You have to go?
Yeah.
Okay, alright. So you can watch this video and you can revise it, okay?
Okay.
So here, this is a cylinder, okay? This is my base, this is my top. These two areas I could find, pi r square, pi r square. Now I'm trying to find out the surface area of the curve. This curve part, the smooth part. And this is nothing but a rectangle actually, if I cut it open. When I fold it again, this becomes a circle. This circle is what? This circle is nothing but the circumference. The 2 pi r that you know about a perimeter or circumference for a circle. And 2 pi r multiplied with the height. So now this is a rectangle. This side is 2 pi r and this is h. 2 pi r. This is a rectangle now. 2 pi r is the perimeter and this is the height. Height remains height. So what you said, Praneeth, that was correct. I was just breaking it down. Yeah. Now you don't have to remember 2 pi r h or 2 pi r square h. You don't have to care about it. You can always visualize this piece of paper. Yeah. And you'll be able to recall, yes, this is how it is. Yeah. So never ever memorize the formula unless that is the only option. There are times when we end up memorizing some formulas because those are axioms which you don't have to prove. That is proven fact, that is written in stone, that cannot be changed. But then everything else you should challenge yourself and question yourself, how is that right? Do I know how it is correct? Can I see if my teacher is right or not? Teachers can be wrong. Many of the teachers are wrong. I could be wrong. I could go wrong many days. So that is when you guys are paying attention, doubting me, validating by yourself, you will end up challenging me and I will not mind. But I will end up learning from you guys as well. Okay? So that should be our focus. So this part you guys understood, right? This is pi r square, this is pi r square. So top area is pi r square, 2 pi r square. And now the curve part, I know the circumference, I cut it open, this becomes a rectangle. This is the curve part, 2 pi r, and this is the height of my cylinder. 2 pi r h, done. Yeah? So you can always write this as 2 pi r into r plus h, if that helps you memorize it. But I would not. I am not a good student. I don't believe in memorizing things. I keep saying that I was not a good student. I was not that bad a student, but my style was different. That's what I'm trying to say. Because if you memorize things, it's very likely that you'll end up forgetting also. Yeah? So understand. Always try to understand, always try to challenge yourself, always try to challenge your teacher. Don't take anything on the face value. You will enjoy maths. And that's what my goal is. Alright? That's what brings us to the end of the class. Any questions, Siva sir?